the sequence analysis of these specimens. I think there is some sense today in looking towards the analysis of these samples in core facilities that are specifically designed to carry out high volume barcoding. I think we can deliver higher quality data, and I think we can deliver it at lower cost. The whole informatics support system, the whole analytical chain is a little bit different from that in conventional genomics facilities. I think at the same time we should encourage the development of capacity to do low-volume sequence analysis in many places. It will be very important for nations to say that we're not just watching this happen, we're participating in it. I think we should also set very strong mechanisms that make it possible for individuals to travel to core facilities at no cost to themselves. And the analysis, the analytical costs would be covered, the accommodation costs and the travel costs. We just must have a mechanism to move individuals. And I'm looking not just at movement of individuals to from developing nodes to central nodes, but I think Canadian students and American students and British students will benefit immensely from the chance to work in the bio-rich region. Some of my students have had that opportunity in the past and just to immerse themselves in a different culture. So I see a two-way flow of students. So that's just a brief synopsis of what might happen in terms of aggregating specimens and seeing the specimens through to analysis. We're going to be generating a lot of data, and we have to think about what we're going to do with that data. I think the wonderful efforts of people here at Guelph, the contributions that have come from our alliances with many collaborators have built a relatively strong informatics platform, and the alliance that developed with the Genomics Consortium. BOL currently has 260,000 records or so. It lives in a single site. Those of you that have visited BIO will see the room that the servers sit in, but when Guelph gets bombed because of its great strategic importance, BOL goes down. We do back it up, but I don't think we want to rely on an identification system for life that lives in a single situation. We need to think about investing money on expanding the informatics platform in a couple of ways. I do think it's very valuable to consolidate the records in a single database, but I think that we really have to look to a very soon future where this database is mirrored at a number of sites. And I think the records should be accessed through national portals. I think it's very important to have that sense of patrimony that if you're interested in life in Kenya, you enter through the Kenyan site or you enter through the Costa Rican site. The annual budget for injecting 1 million records per year is $4 million, is the amount that's been allocated. And what sorts of things would happen? Any of you that have used BOL, it's a rather impressive instrument, but it could be more impressive. So we'll want to try and extend the functionalities of this database and have a much stronger interaction with the informatics community around the world. Establish 3 BOL mirror sites at least. I think potentially the central node nations would be the logical sites. They've got more money to invest, so a mirror site within the European Union. It might make sense to have it in Copenhagen in proximity to the Global Biodiversity Information Facility. A site in the United States, if the funding is there, to in place such a site and support it with personnel. But I think the equally important undertaking is to create these national barcode of life web portals so every nation that's involved in this consortium has a very clear presence. And it tunnels in. If individuals, the taxonomic feeds will soon be accompanied with geographic feeds off of BOL, so all of the records from Costa Rica or Korea can migrate out into the national site. A monitoring of that. And if an individual generates a sequence and wants to identify an organism for Korea, you go in through the Korea portal, the sequence is deposited there, and out comes an identification back through that site, rather than through a generic BOL site. Technology development. We need a couple of rooms of equipment today to carry out this work in a high volume. I think there are 2 things that we need to look at. One is that we need to think about point of contact. I remember Dan's challenge at the very first meeting that we were at. Damn, guy, I thought things were going well until he said, I want to do this for pennies and seconds. Oh, Dan, give me a break. Point of contact barcode analysis is something that a lot of us have focused attention on since Dan set that challenge. But the other opportunity I think that's developing through the wonderful technologies of new highly parallelized sequencing technologies, the possibility of doing environmental barcoding, looking at massive scans of life. May not need to be done in a minute in the field, Dan, but we need to look at hundreds of thousands of individuals at once as opposed to single individuals. And of course, we're seeing technology bubbling up today, PCR machines made by graduate students that run a PCR reaction in 5 minutes and that cost $2 or $3 to fabricate. We want to see the technology become cheaper. This is a sequencing technology, a 10-centimeter plate that carries out Sanger-type sequencing, that reads sequences. Not really quickly, but does it in a physically compact device. So the environmental barcoding notion, that Jansen guy down in Costa Rica with collecting endless heaps of bugs, throw it into a blender. And Mustafa Ranagi was at the beginning, he's here, and he was at the beginning of pyrosequencing. That technology has now been used to create the 454 instrument, which is delivering massive numbers of sequence reads. So the idea here is you take a kilogram of bugs, and from that you get a readout of the species within it. It may take you a week, but it's worth it. And then the handheld device, the field guide for the third millennium, a device that basically takes touch an organism and get enough DNA from the organism and PCR amplify it and sequence it and do the sequence match in that single device. And vision of the handheld barcoding and biological literacy for the masses. I think it's within reach, and I think it will be more in reach if we invest money in the technology stream. $20 million will not go far in technology creation, but it may be enough to motivate the industrial community to get more involved. It's a diagram that looks an awful lot like the one Karen just showed. I don't know how that happened. Program management, do we need management? My own view is if we're going to try and drive forward a research enterprise of this magnitude, that we probably do need some management structures. I would love to see them minimalized, but I think there has to be some management associated with this research enterprise. So this is this International Consortium initiative, what might be involved in it. I think these common elements that have showed up in past ICIs led by Genome Canada, Board of Directors, a scientific steering committee. Something that hasn't really shown up, I think, in the past, are strong national committees. I see the strong national committees as actually being the real workhorses of this initiative, of the barcode initiative. And the fact these national committees would be exerting their work through at various levels, at various intensities of work. iBOL, of course, has played an amazing role in the rise of barcoding, in leading a community of people around this world to understand its relevance to their missions of biosurveillance. So iBOL's role, I think, would be very multifaceted, but one obvious thing that iBOL is doing with extreme efficiency right now is reaching out to all of the organizations that are involved in biodiversity issues on our planet. And that role obviously would continue. And of course, it would be happy news if iBOL could play a strong role in helping organize the internal part of this IC. Something to be discussed, I think, David. So how much would it cost to manage this? I tried to do it for less than $10 million over 5 years. Maybe it could be done with less, half this, I'm not sure. What would the roles of the organizations? The Scientific Steering Committee would try and coordinate the research. If we've got these large research goals, someone has to try and coordinate that activity. We have to, a group like this would have to assemble the financial summaries of investments in the project and take responsibility for assembling some annual progress report towards the goals. The national committees, as I mentioned, would be the workhorses. They would oversee the execution of research within their national boundaries, and they would develop the national research summary.